Today we're gonna take a look at, I guess the first three modules in four. We're gonna take a look at perimeter, circumference. We'll take a look at area and surface area. And when we meet again on Wednesday, next week, all right, we'll kind of finish up the chapter. So as we begin, first we'll talk about perimeter and circumference. And as far as perimeter and circumference are concerned, the perimeter and the circumference measure a distance around an object. For example, for a rectangle, and I'm just going to write some formulas. For a square, just keep in mind that in a square, all four sides have the same length. So when you kind of see these tick marks around your figures, that just means that all of these sides have the same length. So we're going to call a side length S. The perimeter is 4 times S, and the area is S squared, right? The area measures the amount of surface that an object has. The perimeter is measured in a unit alone, for example, feet, inches, centimeters. The area, which is the amount of surface an object has, is measured in square units. So feet square, centimeters square, that sort of thing. For a rectangle, and in a rectangle, the opposite sides are parallel and congruent. So we have the length and the width. So the perimeter of a rectangle is twice the length plus twice the width. And the area of a rectangle is the length times the width. We're also going to talk about a circle. And in a circle, we don't call it the perimeter in a circle. We call it the circumference. So the circumference of a circle is the distance around a circle. And then we have, in any circle, we have the radius. And the radius is the distance from the center to the outer rim of your circle. The circumference is 2 times pi times r. The area is equal to pi times the radius squared. So you got to be careful. In some of the examples, they give you the diameter, and you actually need the circumference, which is half the diameter, to use these formulas. We also have a triangle, and in a triangle, just make it look like a triangle. So on the triangle, we have the base and the height. So for the perimeter, you would just simply add up all three sides, all right? For the area is 1/2 the base times the height. And we will also take a look at a parallelogram, I believe. And in the parallelogram, the area is simply the base times the height. Okay, that's supposed to be a parallelogram. All right, so in order to find the perimeter, you just simply add up all of the side lengths. Okay. So here are the 5 figures that we're going to deal with in the first couple of modules. Now, in the third module, when we talk about surface area, we talk about 3-dimensional figures. So what you see here, these are just 2-dimensional figures. They have a width and a length, but they have no depth. Okay, so they're only in 2 dimensions. Whereas for surface area, we're looking at objects in 3 dimensions. All right, so here are the formulas. And we're just going to take a look at some problems. And I could not find a good formula sheet that just covers all of the everything that we need. All right. Okay, so these formulas are actually going to cover the first couple of modules. All right, so let's take a look at some problems. Number five. Yeah, I got number 5 on here. That's the first one we're going to look at.
Oh, wait a minute. I'm sorry, number 6.
We got number 6 on that too. Okay, so I try to pick the problems that students have the most questions with. Since this one has a fraction, it just says find the perimeter, and we're going to basically add up all the side lengths. The thing about this is it wants you to leave your answer as a mixed number. So in order to find a perimeter, I'm going to add all of the side lengths. So the perimeter is going to equal to 3 1/8 plus 7 plus 9 1/8 plus 5. So I'm going to add up all the side lengths. The first thing I'm going to do is I'm going to add up all of my whole numbers. So 3 plus 7 is 10. 10 plus 9 is 19. And then 19 plus 5 would be 24, right? So I just added up all of my whole numbers. And then I'm going to add my fractions. So remember, in order to add fractions, you must have a common denominator. Right? So notice I do have a common denominator of 8. So I'm going to keep that common denominator, so I don't add the 8s. I keep my common denominator, but I will add my numerators. So 1 plus 1 is 2. So I get 24 2/8, and now I'm just going to reduce. So 2 over 8, that can be reduced down to 1/4. So my perimeter is 24 1/4. So it kind of specifically wants you to answer this as a mixed number. All right, for problem, well, our second example, this is actually problem number 6. We're asked to find the perimeter. So as you look, there are a couple of missing sides on this thing, right? So the first thing I'm going to do is attempt to figure out the 2 missing side lengths. So I'm going to first figure out this length, right? So this is how I'm going to do this. So notice that the entire length of this figure is 16 centimeters, right? So that means if I were to make this thing, let's say a rectangle, this side from the bottom to the top, that would also have to be 16 centimeters. So that means that if this is 8 centimeters, then this length, I'll put it inside here, would also have to be 8 centimeters, right? Because 8 plus 8 would give me 16, right, which would be the overall length. I'm going to do the same thing to find this piece or this missing length. All right, so now I'm going to look at the base of this particular figure. Notice that the base is 22 centimeters long. For the top, I have 10. So I'm going to subtract. 22 minus 10 should give me 12. All right, so 10 plus 12 gives me the 22, and that would give me the missing side length. So now I'm going to add up all of the side lengths. So the perimeter here is 10 plus 16 plus 22 plus 8 plus 12 plus 8 and if I add all of those up together, I get 76 centimeters. So for this particular problem, you have to find the missing side links. So if you sort of make a rectangle out of the whole thing, right, we can find the missing side links. All right, any questions about number 6? All right, problem number 7. It says find the perimeter of the figure, and they want you to use 3.14 as the approximated value for pi, and it says round to at least 1 decimal place. So now, if I look at the top of this figure, notice that it's a half circle. We have the formula for the circumference of a circle, right? So the circle, the circumference is 2 times pi times r. For a half circle or semicircle, if I wanted to find the circumference, I would take the circumference and I would just cut it in half, right? I would just divide it by 2. So that means in order to find the circumference of a semicircle, you're going to use the formula pi times r, right, instead of 2 pi r, because 2 pi r gives you the entire circle. We only want the circumference for the semicircle, so we're going to use pi times r. So I'm going to find the circumference in a couple parts. First, I'm going to find the circumference for the half circle, and then I'm going to find the perimeter for the base. So the perimeter, that's going to equal to pi times r. So that's going to give me the circumference for the top, which is a half circle, plus I want to take the perimeter for that side, which is 3, plus this side, which is 3, plus this side, which is 3. So what's the radius? Okay. Well, now the 3 that they actually give me at the bottom, that would be the diameter. So I'm going to have to take the diameter and I'm going to have to cut it in half. So half of 3 is 1.5, right? So my radius should equal to 1.5. So I'm going to take this formula for the perimeter. I'm going to substitute in 1.5 for r, and I'm going to simplify. So this is going to give me 1.5 times pi, which I'm using as 3.14, plus 3 plus 3 plus 3. Right, those are the length of the other sides. And now if I just simplify this on my calculator, I have 1.5, which is the radius of the semicircle times 3.14 plus 3 plus 3 plus 3, and we get 13.71 meters as the perimeter. All right, and that was number 7. Okay, so they didn't actually give us the radius, they gave us the diameter, and we had to cut the diameter in half. All right, any questions about number 7? All right, now number 15. This is a Sierpinski triangle. And it says the diagram shows one stage of what is known as a Sierpinski triangle. Each triangle in the diagram has equal sides, right? So it's an equilateral, all of these things are equilateral triangles. The big one is an equilateral triangle, and those smaller triangles are an equilateral triangle. It says the larger triangle is made up of 4 smaller triangles, right? So I have the big triangle, and then I have 4 triangles within. If each side of the large triangle is 2 inches, right? So that would mean that this would be 2 inches. This is 2 inches, and this is 2 inches. And each side of the smaller triangle is 1 inch. What is the perimeter of the shaded region? So now this is what this question is asking for. Well, let me just put in, it says if the sides of the smaller triangle are 1 inch, that would mean that this is 1, this is 1, this is 1. Okay. All of these things are going to be 1. And we're asked to find the perimeter of only the shaded region, right? So I can find the perimeter for this first shaded region, right? If each triangle has a perimeter of 1 inch, the perimeter for this first shaded triangle would be 3 inches, right? Because 1, 2, 3, that would be 3 inches. The area of the second shaded, the perimeter, excuse me, of the second shaded triangle would also be 3 inches. The perimeter of the third shaded triangle would also be 3 inches, right? So 3 inches plus 3 inches plus 3 inches should equal to 9 inches. All right. Is everybody okay with this? This is a weird kind of, because it gives us the fact that each side of the smaller triangle is 1 inch. So each one of these sides is 1 inch. And it wants to know the perimeter of the shaded region. So I would have to find the perimeter for all 3 triangles, and I would just add them together. So we get 9 inches. Any questions about number 15?
I thought the perimeter was on the outside.
Well, it is.
So for that one, I mean, it.
Because like if you,
I'm probably just looking into it too deeply, but
the first time I did also, I'm like, what are they really asking? But if you look at this first triangle, right? Because it's shaded, and it says that each side of the smaller triangle is 1 inch.
Yeah.
So I could find the perimeter for this triangle, right, which would be 3 inches.
Yeah.
I can also find the the perimeter of this triangle, because it's shaded, right?
Yeah.
So that would also be 3 inches. And I can find the perimeter of this shaded triangle, which would be 3 inches. So just making 4 triangles and it's leaving one unshaded, and it wants to know what's the perimeter for all of the shaded triangles.
Yeah, I mean, the fact that the triangles are touching is what's throwing me.
Right.
Because to me, it looks like it should be 2, 4, should be 6, because you're just doing the
2,
outside.
4, 6. That's
Yeah.
right. That's right. That's
Like,
right.
if somebody said, "Get me the area of the Pentagon, the perimeter of the Pentagon in Washington," I wouldn't. The center's hollow.
That's right.
Like I wouldn't.
That's right.
I wouldn't be like, well, I'm going to need fence to go on the inside. No, I just need fence to run along.
The outside of it.
Yeah.
That's right. But like if you were thinking about that fence concept, it would want the fence around this triangle, around that triangle, and around that triangle.
Yeah, it's just that they
I got
touch
you.
together through me.
Okay. All right, that was number 15. All right, now in the next section, we talk about area. Okay, and we're going to use these same basic formulas. The same formulas from earlier for the 5 objects. Right. So the first one is problem number 3. This is a parallelogram. Probably been a while since you even seen a parallelogram. I want to find the area, so I'm simply going to multiply the base times the height. So the base on this thing is 9. The height is 5. So if I multiply 9 times 5, I get 45. And since we're talking about area, the units are squared. So this will be 45 square centimeters. All right, for example, if you wanted to go into the carpet shop and get some carpet, you wouldn't just say, I want, 20 feet of carpet. You would say, I want 20 square feet of carpet. All right. So area is measured in square units. Perimeter is measured in the unit alone. All right, the next one we're going to look at is number 5. And here you're asked to find the area for the circle. So that formula is the area is equal to pi times the radius squared. And you got to be careful, right? They give us the radius. Sometimes they'll give you the diameter, which goes from one rim of the circle through the center to the other rim. We only want the radius. So we're given the radius. So I'm just going to substitute 9 into this formula. So A is equal to pi times the radius, which is 9 squared. 9 squared is 81. And they want us to use 3.14 as pi. So you do get like a slightly different answer. Like on this calculator, there is a true value for pi. So if I were to put in 81 pi, it gives him like 254.496. However, if you use 3.14, you will get a slightly different answer. All right, now let's take a look at number 10. It says that a garden is rectangular with a width of 10 feet and a length of 16 feet. So I'm going to sketch that out. So we got a garden. It's 10 feet wide and 16 feet in length. All right, so it's like some flowers in here. So however flowers are supposed to look. So that's the garden. It's surrounded by a walkway 2 feet wide. How many square feet of area does the walkway cover? Okay, so this is the garden, so we don't want to walk in the garden, but it's surrounded by a walkway that's 2 feet wide. So this is like the walkway And this is not drawn to scale by any means. So this is, the walkway is this area here, right? Because we don't want to walk into the garden. We want to know how many square feet of area does the walkway cover. Okay. So we know that it's 2 feet wide. So this is going to be let me just put my dimensions. So this is going to be 2 feet, right? That would be the width of this walkway, 2 feet. This would also be 2 feet. And if I go down, this is 2 feet. This is 2 feet. So it's actually like I have 1, 2, 3, 4 different areas. I'm going to add up, take this area. I'm going to call it A1. I'm going to take this area. I'm going to call that A2. I'm going to take this area, that's A3, and this area is A4. Hold that up a little bit. All right, so once again, the garden is 10 feet by 16 feet. The walkway around it is 2 feet wide, right? So this is where these 2 feet come in, right? 2 feet and 2 feet. First, let's find the area for the first rectangle. So in order to find the area for the first rectangle, I need the length and I need the width, right? So I know it's 10 feet and then the walkway is 2 feet. So my length is 10, the width is 2. So when I multiply that together, I get 10 times 2, which is 20 square feet, right? That's for my first rectangle. Now let's find the area. Any questions about that? Right, because it's 2 feet wide and it's 10 feet, so I'm multiplying 10 times 2 to get 20. Now we're going to find the area for our second rectangle. So that's going to equal to the length times the width. I know that the width is going to be 2 feet, right? But what is the length? 20 feet, right? Because I have to take 16 plus this 2 feet plus this 2 feet. So that should give me 20 feet. All right. Notice it's 2 inches from the garden. So that's going to give me a length of 20 feet. And then the width is still 2, right? So the area for the second figure is 20 times 2, which is 40. So that's 40 square feet. Now I'm going to find the area for the third region. So now the area of the third region should actually be the same as the area for the first region, right? Because it's 10 feet long, it's 2 feet wide. So 10 times 2 should be the same 20 square feet. So that's 10 times 2, which is 20 square feet. And I'm going to find the area of the fourth region. And then the area of the fourth region should be the same as the area of the second region, right? So the area of the fourth region should also be 20 times 2. All right, so the area of that fourth region is 40 square feet. And to find the total area, I'm just going to add them all up. All right, so the total area is 20 square feet plus another 20 plus 40 plus 40. So altogether we should have 120 square feet. Any questions about that one? So just map everything out. I split this up into 4 different regions, found the area for each region, and added them together. All right, that was number 10. Okay, now we're going to get into the next section, which is actually surface area. And I'm going to move this down some. All right, so before we get into 4.3, let's take a look at some formulas. All right, so now for the surface area, we're finding the amount of surface, in this case, that a 3-dimensional object has. So the 3-dimensional objects that we're going to look at is one is called a prism. So a prism is going to look something like this. Where you're going to have a length, a width, and a height. So I'm looking for the surface area, right? So I want the amount of surface that all 6 sides of this thing has. So the surface area is equal to 2 times WL plus H times L plus H times W. All right, and that's going to give me the amount of surface an object has. In the next section, we talk about volume, and volume is the amount of water something can hold. Okay, so surface area is the area around the object, but volume is how much water an object can hold, and volume is measured in cubic units. Okay. All right, now there's something called lateral surface area. So let me just explain the difference. A lateral surface area, and there's a totally different set of formulas. For our formulas, we're finding the total surface area. Lateral surface area would be the area of all the sides, but not the base. Okay. So this formula gives you the area for all sides. The lateral area only gives you the area of everything minus the base. Okay, the base is what that solid is resting on. So this is the surface area for a prism. Next, we're going to look at the surface area for a cylinder. So for a cylinder, you have a circular base, right, sort of like a Coke can. You also have a circular top, you have a radius, and you have a height. So the surface area for a cylinder is going to be 2 times pi times r times h plus 2 pi r squared. The first part of this formula, this gives you the area of the shaft. The 2 pi r, this gives you the area of the top and bottom. So remember that the formula for the area of a circle is pi r squared. Since you have a top and since you have a bottom, we have to multiply that pi r squared by 2 to find the area for the top and the area for the bottom. Because there's a certain problem in the homework that kind of plays on the top and the bottom. And we also are going to look at a sphere. All right, the surface area of a sphere. Then we have a radius r. The surface area is 4 times pi times the radius squared. Okay, so these are the 3 solids that we're going to take a look at in the third part of Module 4. All right, so I'll give you a second to copy those down. All right, so let's take a look at some examples. The first is problem number 2. And it just says find the surface area, and this is a prism. So we're going to use the formula for the prism, which is A is equal to 2 times W times L plus H times L plus H times W. I'm going to substitute L for 8. That's my length. The width is 12. And the height is 8. Right, so I'm just going to substitute those into the formula. So and I should change this to S for surface area. So that's going to equal to 2 times W times L. So that's 12 times 8 plus H times L, which is 8 times 8, plus H times W, which is 8 times 12. And so that's going to equal to 2. And then 12 times 8 is 96. Plus 8 times 8, which is 64. Plus 8 times 12, which is 96. So I'm going to add up 96 plus 84 plus 64 plus 96. And 96 plus 64 plus 96. I get 256. And 256 times 2 is 512. So we get 512 square miles. So remember, we're finding the amount of surface that it has. All right, that is number 4. Excuse me, that's number 2. Problem number 4 wants us to find okay, my figures are running together a little bit. Okay, here we're asked to find the surface area of a cylinder. So notice it says that the cylinder is closed on both ends. If this thing said the cylinders were open on both ends, we would use the same formula, except we wouldn't use the second part. Right, because the 2 pi r squared, that represents the area for the top, which is a circle, right? And the area for a circle is pi r squared. And the area for the bottom is another pi r squared. So altogether we have 2 pi r squared. If you did not have the top and the bottom, you would not use the second part of the formula. So notice that they specifically tell us that the top and the bottom are closed. So I'm just going to use the formula. So S is equal to 2 times pi times r times h plus 2 pi r squared. I want to substitute r for 3 and h for 6. So this is 2 times 3.14 times 3 times 6 plus 2 times pi, which we're going to substitute for 3.14 times r, which is 3 squared. So now I'm just going to put all of this stuff into the calculator. So 2 times 3.14 times 3 times 6 plus 2 times 3.14 times, and then 3 squared is 9, so I'm just going to put in 9. And once we simplify, we get 169.56 square yards. We're talking about area. All right, what number 4? Any questions about number 4? Okay, next is number 6. And we have a sphere, and we're asked to find the surface area for a sphere. So the formula for the surface area is 4 times pi times r squared. And I'm simply going to substitute r for 4. So this is equal to 4 times 3.14 times 4 squared. So this is 4 times 3.14 times 4 squared, which is 16. And we get 200.96 square centimeters. So just a matter of plugging and chugging into the formula. Now the next two, number 9 and number 13. All right, these are more than just a little bit of plugging and chugging, okay? Number 9 says find the surface area of the figure. Use 3.14 for pi and round to the nearest hundredths if necessary. So I have a semicircle and I have a cylinder. But notice on the cylinder, I don't want the surface, I don't want the area for the top of the cylinder. I only want it for the sides and for the bottom. We have the formula to find the surface area for a sphere, right? So for a sphere, the surface area is 4 times pi times r squared. For a hemisphere, the surface area is going to be 4 pi r squared, but we're going to cut that in half. So the formula I'm going to use to find the surface area for the top of that figure, that silo, is going to be 2 pi r squared. Right? So the surface area is going to equal to 2 pi r square, right? And that's only the surface area for the dome part, the top. Now I want to find the surface area for the cylinder, but I only want the surface area for the bottom and the sides, not the top. So this is going to be plus. Now, if I look at my formula for the surface area of a sphere, go back up for a second. I get 2 pi RH. That's going to give me the lateral surface area. I only want the area for the bottom, not the top. So instead of 2 pi r squared, I'm going to use pi r squared. So here's what my formula should look like. So 2 pi r squared, that gives me the surface area for the dome, the top, plus 2 pi RH. That's going to give me the surface area for the shaft. Plus pi r squared, that's going to give me the area for the base that it sits on. So I'm getting the surface area for the dome, which is the top part, which is a hemisphere. I want the area for the shaft, which is 2 pi RH. And I want the area for only the base, which is pi r squared. So in this formula, I'm going to substitute r for 3 and h for 9. So this is going to equal to 2 times 3.14 times 3 squared plus 2 times 3.14 times 3 times 9 plus 3.14 times r squared. All right. So now if we put this into the calculator, two times 3.14 times 3 squared is 9 plus 2 times 3.14 times 27, because 9 times 3 is 27, plus 3.14 times 3 squared, which is 9, and we get 254.34 square yards. So be careful on number 9, right? Because if you were to use the 2 pi RH plus 2 pi r squared, you're going to overshoot the area because you're including the top, when the top part of this cylinder is a dome. All right, and the last one, problem number 13. And there's generally some questions about problem number 13. Right? And it deals with a sheet of paper. It says making a cylinder, make an 8.5 by 11 piece of notebook paper into a cylinder is shown. It says use the diagrams. So here's an 8.5 by 11. You can make a cylinder this way, right, which is that top diagram, or you can make the cylinder this way. Right, so it's 2 ways to make the cylinder. It says if the length of the cylinder is 11 inches, so they're using this top part, what is the largest possible radius round to the nearest thousandth? Okay. So if you look closely, so this is 11, this is 8.5. So my circle is actually, it has an 8.5 circumference, right? Because the circumference is the distance around an object. So if this is 8.5 flat, when I fold it in a circle, the length is not going to change, right? That's still going to be 8.5. Right? So that's this first diagram. So it says find the largest possible radius. So I'm going to set up a little bit of algebra. So the circumference for a circle is equal to 2 times pi times r, right? And we know that the circumference should equal to 8.5, right? Because if my length is 8.5, when I fold it into a circle, that still should be 8.5, which is the circumference. So I'm going to set this up as an equation, and I'm going to solve it for r. So I'm going to substitute 8.5 for c. So 8.5 is equal to 2 times pi times r. The opposite of multiplying r by 2 pi is to divide by 2 pi. So I'm going to divide both sides by 2 pi. So I get something that looks like this. R is equal to 8.5 divided by 2 pi. Right? So R is equal to 8.5 times, well, divided by 2 times 3.14, right? So R is equal to 8.5 divided by 6.28, right? Because 2 times 3.14 is 6.28. And if I divide the two, 8.5 divided by 6.28, I get 1.353. So the radius is 1.353, right? If we round to the nearest thousandths. Okay. So that is the largest possible radius, right? And that's A. B says using the radius from part A and the formula for surface area of a cylinder, find the surface area of the roll notebook paper and round to the nearest tenths. So this is B. So now if I'm finding the surface area for this sheet of paper, notice that it does not have a top or a bottom. The top is open and the bottom is open. So I'm only going to use S is equal to 2 times pi times r times h. I'm not going to use the plus 2 pi r squared because for this sheet of paper, right, it has no top and no bottom. They're open. So I'm going to substitute r for 1.353, right, which we just found. And the height is going to be 11. So I'm going to multiply all this together. So S is going to equal to 2 times 3.14 times 1.353 times 11. So the surface area should equal to 2 times 3.14 times 1.353 times 11. And we get 9.35. Okay, round to the nearest tenth. So that's 93.5 square inches. Right, since we're talking about area. And then the last part says find the area of the original piece of notebook paper by multiplying the length and the width. So C, the area is equal to the length times the width. So the length is 11, the width is 8.5. And I should get the same thing as I got for the surface area, that 93.5, right? Because it's the same sheet of paper, same area. So I'm going to multiply 11 times 8.5. And we get 93.5 square inches.